Hey guys, in today's video we're going to be talking about solving absolute value inequalities. We looked at absolute values before in equations like this one, and we'd break this into two parts where a is positive and a is negative. But now we're going to be looking at inequalities, and here are two rules that you guys should definitely write down in your notes. And I'm going to go on to the next slide and explain why these hold true. So for the first one, where the absolute value of u is less than or equal to a, and we'll get that negative a is less than or equal to u is less than or equal to a, let's look at this one example, with the absolute value of x less than or equal to 3. So here, this rule will be saying that negative 3 is less than or equal to x is less than or equal to 3. So why is this true? Well, let's put negative 4 in for x. So the absolute value of negative 4 is less than or equal to 3. Well, the absolute value of negative 4 is just going to be 4. And this is less than or equal to 3, and well, that's not true. So we can rule that out. So that's why we have to rule everything greater than negative 3 here. And then obviously, when you plug anything greater than 3 in for the absolute value of x, you're going to get something greater than 3, and that won't work. So that's why that one works the way it does. And let's try when x is greater than or equal to 3. And so our rule here will be x is greater than or equal to 3, or x is less than or equal to negative 3. And so why does this hold true? Well, let's plug in negative 2 this time for x. And, well, the absolute value of negative 2 is just going to be 2, which is greater than or equal to 3. Well, that's not true, so we can rule that one out. Anyways, the statement will hold true for any x which is less than or equal to negative 3. And so that will give us a number greater than 3. And so those are the reasons why those two rules work. So let's look at some more intense examples. So before we start this example, let's also make sure we remember that a has to be some positive number. If a ends up being a negative number, we can instantly rule out that there are no real solutions. So let's look at this example. So with this rule, we can restate this question as okay. And so we've worked with problems like this before. All I have to do now is break it down into two parts. So we'll have negative 9 is less than or equal to, and we'll have okay, so now that we've broken up into two parts, let's solve each one. So the goal here to the left is to get x by itself. Okay, so here we'll end up getting negative 1 is less than or equal to x. Now we just do the same for the right one. I'm going to go ahead and pause the video and come up with the solution in 1 second. So on the right-hand side, I ended up getting x is less than or equal to 5. So now we just write it into our expression. It should be negative 1 is less than or equal to x, which is less than or equal to 5. For this example, we're going to be changing up our signs. So instead of being less than or equal to, we're going to be looking at greater than or equal to. But before we can even break this part apart, we have to make sure we subtract our 3 here and get our absolute value all by itself. And so we'll end up getting all right, so now that we've gotten to this point, break it up into two parts. So we'll have x plus 14 is greater than or equal to 14. And we'll also have or okay, so we've broken up into two parts. Let's go ahead and solve. Here, all you do is subtract the 14 to get x by itself. So we'll have x is greater than or equal to 0. And we'll subtract the 14. We'll have x is less than or equal to negative 28. Cool. So now our final solution is just going to be x is greater than or equal to 0, or x is less than or equal to negative 28. All right, let's work on this last example. So here, first step, subtract the 5, subtract the 5. Okay, so now we'll break it up to this expression right here. This one, though, I want you guys to work on. So right now, pause the video and work it out yourselves. And unpause when you have a solution and see if our solutions match up. So what I ended up getting was x is less than 10/3 and x is greater than negative 2. So let's bring this all together into one common expression. And so we start with the smallest number first. We say negative 2 is less than x, which is less than 10/3. Now something we haven't done yet in this video is write our solutions in interval notation. So let's go ahead and do this one. And here, these are open. Intervals are just less than or greater than. So we'll have open brackets, negative 2, comma, 10/3. And that would be our solution in interval notation. I know you guys remember from slide 3, we got an answer similar to that, and we wanted to write this one in interval notation. Well, these are less than or greater than or equal to, so we have to use closed brackets, and so it looks something like this. Okay, and that's how we would write it in a closed or interval notation. And for this slide where we're looking at the ors, we can just leave it like this. It's a lot easier just to leave it like this. That's all. Okay, so I hope this video was beneficial to you guys. For class tomorrow, I want you guys to work on these solutions or these problems and bring your solutions to these problems to class. All right?